This video is on chapter 39, sigma notation, sometimes called summation notation. So chapter 39 is about using this notation to express summations. And most of the examples in this chapter, I think, are fairly straightforward in the notes. There's one type of example that I want to explain a little bit in the video, and that is the idea of what we call a telescoping sum. And so we're going to sum k equal 1 to 100 of this expression. Now, when you look at the formulas that are given in the chapter, there isn't a formula for this type of summation. So what we do is we write out some of the terms and we see a pattern. So we start at k equal to 1, so we have 1/3 minus 1/5 plus 1/4 minus 1/6 plus 1/5 minus 1/7, etc., etc. And so we're going to sum this from 1 to 100. And so I don't write the middle terms, I just have the dot 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 here. And so then we're going to write out the last few terms. Positive 1/100th minus 1 divided by 102 plus 1 divided by 101 minus 1 divided by 103 plus 1 divided by 102 minus 1 divided by 104. And this is called a telescoping sum or a collapsing sum. Why? Well, you'll notice that most of these terms cancel. Negative 1/5, positive 1/5. Negative 1/6, positive 1/6. Here is a negative 1/7. Where does a positive 1/7 come? It comes when k is equal to 5. And we come down to the end. And we see a negative 1 divided by 102, a positive 1 divided by 102. And what is left? So we have a positive 1 divided by 101. When did the negative 1 divided by 101 come? It came when k was 97. Now we have two terms left at the end though. We have a negative 1 divided by 103 and a negative 1 divided by 104. Why don't those cancel? Well, in order to have a positive 1 divided by 103, k would have to be 101, but it stops at 100. Likewise, in order to have a positive 1 divided by 104, k would have to be 102, but we stop at 100. And what I want you to notice about a telescoping sum is what's the difference between k plus 4 and k plus 2. The difference between k plus 4 and k plus 2 is 2. What happened? We have two terms left over at the beginning and two terms left over at the end. K plus 2 and k plus 4 differ by 2. And so we have these two terms at the beginning did not cancel, and what didn't cancel at the end, this one and this one. So this whole sum collapses, or as we say, telescopes, because you push it together, and the middle collapses. We have two terms at the beginning, two terms at the end. Part H of this example is similar. We have 1 divided by j plus 1 squared minus 1 divided by j squared. And we look at this summation. We're starting at 3 instead of 1. So we have 3 plus 1, so we have 4 squared. Minus 1 divided by 3 squared, plus 1 divided by 5 squared, minus 1 divided by 4 squared, etc., etc. And we'll notice the pattern. We have our positive 1/4 squared, our negative 1/4 squared. We have a positive 1/5 squared, a negative 1/5 squared. We have a negative 1/3 squared. Did a positive 1/3 squared appear? No. In order for that to happen, j would have to be 2, but j starts at 3. So this term does not cancel. Now what happens at the end? Let's start at 98. So we have 98 plus 1 is 99, so we have 1 divided by 99 squared. Minus 1 divided by 98 squared, plus 1 divided by 100 squared, etc., etc. Okay, so we have our positive 1 divided by 100 squared and negative 1 divided by 100 squared. Same thing with the 99s. All right. What about the negative 98 squared? We had our positive 98 squared when j was 97. What did not cancel? The positive 1 divided by 101 squared. In order to have a negative 1 divided by 100 squared, j would have to be 101, but j stops at 100. So that term is left. So there is one term left at the beginning and one term left at the end. What is the difference between j plus 1 and j? It's 1. So the difference between j and j plus 1 is 1. We have one term left at the beginning, one term left at the end. The difference between k plus 2 and k plus 4 is 2. We have 2 terms left at the beginning and 2 terms left at the end. So the differences in how we index these, so the differences in how we label these, gives us a clue as to how many terms will be left at the beginning and how many terms will be left at the end.